Let's begin to understand the simple sort. What is given to you? Which means, what is the input? Input is an array, right? An array of 10 elements. This is clear? Now, what is the expected output? Expected output is the same array is sorted and returned, which means it's an in-place algorithm, right? That is important to understand. We are not generating a new array which will have the sorted numbers. No, here whatever you are given input, and you will be updating the same input data structure and returning it. Therefore, it's an in-place algorithm. So here the output is in-place array, which is the same as your source array. Hope now we have understood what is input and what is output. Let us get into the core part of it. What is the algorithm? What is the simple sort algorithm? So simple sort algorithm works in simple steps. Step 1, you take the given array, right? For understanding, I'm drawing an array here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 elements, okay? So from 0 to 9 as an index. And now I take some random numbers, 15, 2, 3, 6, 1, 15, 4, 9, 7, 2. Well, so this is your given array. Now, how does simple sort work? Let us understand the algorithm. Step 1, you start from the beginning of the array and then take another index to traverse. Start again that number also from the beginning. You start comparing the first index with all other elements in the array. Let's take, if you have taken index as 0, which I am referring it with I, and then the second index as j, that also begins at 0. Now these two, the first index stays here, the second index also begins from 0. Then you start comparing these two elements. So for example, 15 compared to 15, which is same. So here the comparison is, if you want it to happen in ascending order, you will compare it with less than. If you want the array to be sorted in descending order, you will compare it with greater than. You will understand what do I mean by that. So 15 is less than 15. So this is not true. Nothing is changed. Now you have to iterate through the complete array. Therefore, your j is incremented to 1, right? So here what happens, your 15 is compared with 2. What will be the output? This is not going to be true. So there is no change. And you will continue for all the elements and do the action. So what is the action? What is the action that you are doing here? So here you compare 15 with 3, 15 with 6, 15 with 1, there is no change. 15 with 15, no change. 15 with 4, no change. Rest of all the elements are smaller than 15. Therefore, in the first iteration, there is absolutely no change to the given array, right? Then let's see what happens in the next iteration. So now the I is incremented. So your I stays here. J again restarts from 0. So 2 is compared with 15, right? So your array of I, which is 2, less than j, array of j, which is 15. So this is true. Your 2 is less than 15. Now do the action called swap. Swap these two elements. So which will become new array becomes 2, 15, and the rest of array remains the same. So now you continue. Where is your I? I is at this place. And what is at I index right now? 15. So now you will begin to compare 15 with the rest of the elements. As we have seen in the previous example, right? So 15 is compared with all the elements will remain there itself because the 15 is the largest value in the input array what we have today. Well, so likewise you compare with all the elements. So your j is iterated every time the I value changes, and I will be iterated n times. From 0 to n, your I will be iterated. So every time your I changes its value, that is increments its value, your j restarts from 0. Well, so that is the algorithm. Let me simplify it and write the 4 steps that we have discussed here. And from there, how do we translate that series of steps into code, we will see.